Hi, welcome back to module 4 of Grokking Artificial Intelligence of Things. So this module will be talking more about the cloud and how the cloud can actually contribute to the artificial intelligence of things. So this is the last module of all the 4 modules that we've talked about so far. So the first module, we talked about how we can collect the data. The second module, we talked about how we can connect, actually pass this information on into the processing part of the cloud or the artificial intelligence of things network. Then we spent quite a bit of time on the machine learning and artificial intelligence portion. And finally, we come to how we can actually process this information using the cloud. So this set of videos is divided into the first portion. I'll talk a little bit more about the services from Azure, from the Amazon Web Services or AWS. Then I'll talk about Azure, which is from Microsoft. And lastly, I'll talk about the Google IoT suite. In the other set of videos, I will talk a little bit more about the other providers, which is basically from IBM Watson. Then we have the China-based cloud providers, Alibaba Cloud, Tencent Cloud, and finally the Huawei Cloud. So Amazon is actually the world's largest cloud service right now. That definitely has a very rich range of services for just normal cloud computing services, but especially for the IoT related services. So let's jump in. So first of all, I gave you the URL that you can use to actually just take a look at some of the services that are available from Amazon for IoT. So it's group under this thing called the AWS IoT services, which are IoT services for industrial, consumer, and commercial solutions. And as you can see from the blurb there are millions of devices in the homes, in factories, in oil wells, in hospitals, in cars, and thousands of other places. And with all these services, typically, in order to collect and process this data from these billions of devices, you need quite a sophisticated infrastructure. As I mentioned before, in the past, before cloud computing came to be, people used to have to invest in the infrastructure and the servers and the machines to do the processing themselves. But today, with the cloud services being available, it is no longer something which you need to pay upfront in terms of the capital investment, but you can actually rent as a utility these services from a cloud provider like AWS. And you can see that for AWS, at least they advertise themselves as having a very broad and deep range of IT services. They definitely tout the security, which is definitely a concern for IoT devices, because they are actually sending in data being collected in from the real world. And oftentimes the decisions being made also have real world impact. And then of course, AI is actually a key component now. So better or superior AI integration. So we can see that this is a good provider for the artificial intelligence of things. Largely, AWS is pretty proven in terms of scalability. It definitely has millions of servers being made available for you to use as you need on demand. So we take a look at some of the services that's actually provided by AWS. So there are 3 use cases that I'll talk about. So firstly, you can see that in the agricultural sector, we can actually gather information from sensors on the farm. So so this is a hypothetical situation. So on the vegetable farm, farmers can identify vegetable growth stages to increase crop yield. So how much fertilizer you need, how much watering you need to do, and when the crop can actually be harvested. You can plan this in advance if you're able to better predict the time at which these things actually occur during the season. And by being able to better predict the best timing, you will also ensure a higher quality. So this use case is classified under predictive quality. So right at the bottom here, you have soil sensors, right, which have a wireless connection. So they are probably using some simple wireless connection, and the information is not sent to the cloud directly, but maybe sent to a gateway, and from the gateway is actually forwarded to the cloud, where the Amazon services is basically called the AWS IoT core. So this in the IoT core, the sensor data is sent there and it is actually stored and analyzed. So this is the main part that's actually receiving the inbound data from the external network of sensors. Now, the sensor data needs to be processed. It is basically enriched with additional information, not coming from the sensors directly, but maybe additional information coming from other sensors, like such as the location, rainfall information, and other weather prediction information from maybe a weather service. So AWS IoT analytics is that component that does the additional processing rather than the communication portion that storage portion that we see in the IoT core. So we are also able to perform some amount of prediction based on the input data so that we can analyze the trend and find out which is the most optimal amount of watering and when is the most optimal time to actually do the watering. Now, these AWS models, they can, of course, run in the cloud, but for it to be accessible to the farmer in a more timely manner, there's this additional extension where the models are actually deployed on the edge device, for example, on the farmer's handphone, and the machine learning models that we've learned about in the previous module, they do not only need to, they do not necessarily only can run in the cloud, they can also, these days, be passed to the end device, the edge device, like the mobile phone, and the models that are trained that can be executed, or what you call AI inferencing, can be carried out at the edge on the device itself. So one of the SDKs that can do this is what we call the AWS IoT green grass framework that is basically focused on this edge AI inferencing. That means the models that you build in the cloud, they are not executed in the cloud, but they are transferred down to the edge device, like your mobile phone and or other devices that can use, like a tablet or something. Okay, so this is a scenario. Now, if we actually take a more technical view of this, you can see that what we do is that we collect the data again from where it is, right? And it's actually forwarded. Now, this is actually a slightly as the AWS industrial using predictive quality. So the data is collected. Maybe just now it was in the farm, but you can also collect the data from a factory. For example, automation, right, using OPC UA, and they are actually collected from various points and basically forwarded to the IoT core, as shown here, right, and the IoT events actually converts the raw information into events. So the raw information basically is just sensor data directly, but you need to actually interpret what the sensor data is meaning, and then that is basically going to generate what we call events. And the events are then forwarded to engineers who may actually need to look at it if there's something that is of concern. And of course, again, the IoT analytics component, which does the prediction on where's the best watering. You can see that it's connected to the IoT core. SageMaker is Amazon's AI tool that helps you to build models automatically rather than you doing all the hand training yourself. It's basically a set of AI tools that helps you to build models with some amount of automation. Now, data that is being uploaded in different forms, they may actually go into a data lake rather than just going into the IoT core itself directly. So again, this information that's in the lake can be passed to the SageMaker. And as mentioned before, if the AI may sometimes not be doing the prediction in the cloud itself, within the AWS cloud, but actually send back down to the edge device where the prediction is doing, the AWS IoT green grass. Let's take a look at another example. So asset monitoring or monitoring the valuable assets on the factory floor is one of the very common use cases. So in a manufacturing plant, equipment downtime would impact your production, and the health of the device is very important. So the cloud lets operations staff know the health and status of the equipment to prevent productivity and efficiency loss. Same as before, sensors on the factory floor, they gather the information and then they actually upload this into the cloud, which the point where which is collecting information is called the AWS IoT core. So this information is again sent here through the various protocols. It could be MQTT, it could be QP, or any of the protocols that are being supported at the factory floor itself. Okay, so AWS IoT core actually supports most of the commonly used IoT protocols that we've been talking about earlier. So next, after the data has been sort of received and stored, it will then be used for the IoT analytics portion to build dashboards so that the engineers can understand the data and then make decisions about it. Right. So IoT dashboards, they do not build, it's more focused on actually human usage rather than AI directly. But with the data that a human can see, you can see that the dashboard can visualize the asset's health and performance and then basically predict when is a good time to actually take a look or reconfigure the asset so that it will actually be improved before actual failure happens. Right, and it's actually integrated through the dashboard portion of QuickSight. So let's take a look at the technical architecture for this kind of use case. So you can see that the AWS IoT infrastructure is quite similar as before. Again, is using OPC UA server to collect the information, the IoT devices to gather the data. So it's again passed to the IoT core that stores the data, right? And there's a dashboard to just monitor the performance of the input inbound data as well, just to see things are working properly. Now, from the data from the IoT core is then passed to the IoT's events that translates the raw data into events and then basically send alerts to engineers, or it may be passed to a function that does the machine learning portion. You can see that there are so this is the Lambda function, which is a serverless backend service. And from the IoT core, it actually goes to the AWS IoT analytics as before, and this actually will make some predictions, and it's also forwarded to the QuickSight or the dashboard portion so that the human operations manager can take a look at it and then make appropriate decisions on what it should be done to improve the situation. Last one is actually the same thing related to a factory floor, but in this case, not just monitoring the health, but really to make a forward prediction to actually prevent further breakdown from happening. So what we call preventative maintenance or predictive maintenance. So in the oil refinery, predictive maintenance pays off producing an extra quarter or half a barrel per well each day, meaning an extra 200 million per year of incremental revenue. So the data is actually collected with sensors because this is using the AWS services. They typically refer to the AWS IoT Greengrass, which is the framework running on the edge to collect data and also to run edge-wise prediction models that you download onto it. But IoT core is actually pretty much supporting almost all the well-known protocols. So you can actually, in theory, use other edge frameworks that can gather data for you and then just forward from the gateway to the IoT core. It need not be restricted to just AWS Greengrass. Right. So this is the idea, right? When we have standards, then we can actually use alternatives instead of just depending on one of the items, the whole framework provided by the vendor, in which case you have a vendor lock-in. So standards do help to prevent that sort of situation from being too common. But of course, if the entire solution is already sort of prepared for you and you have a ready solution that's already using the IoT green grass, you shouldn't stop you from using it, because that would mean that the integration is already seamlessly done and don't need to bother about interoperability testing, etc. So it saves you a lot of headache. If it's available, you can just use it. So when a connection is actually available, the data is forwarded again to the IoT core, which collects the information, and then we send it over to the IoT analytics to do further analysis of the data to make some further predictions here. And finally, it goes to the machine learning portion, which does the actual prediction on what's the trend, like when is the likely failure going to happen, right? So this is actually trying to create a more proactive service where you don't just react to the data, but you sort of predict what will happen next, and then you do the appropriate actions based on the proactive scenario, based on the predictions that you make. So we can see that the reference architecture is like as before. The data is forwarded over to the IoT core, and then there are some rules that are run, okay, to collect the data, and then the analytics portion gives you a dashboard, and you can even run your Jupyter notebook, which is a very well-known used tool by data scientists to build models using coding, like using Python inside the notebook. So this is ready to just build more sophisticated models than what you can just do with a normal shrink wrap solution that you have in the AWS Analytics. So the notebook is a good facility to allow more customization by your data scientists. And finally, there is actually 6, which is a Docker image to basically run the code that's coming from the models, I believe. So that is actually the suite from AWS. So you can see that actually they capture very much the whole chain, right? Getting the data, various ways of actually converting it into events, and also to analyze the data for trends, and then build machine learning models using various tools like the IoT analytics, the Jupyter Notebook, or even SageMaker, which is a drag and drop automated machine learning tool provided by Amazon. So that's actually AWS, a pretty comprehensive, well established cloud suite for IoT. Next, we will take a look at an equally comprehensive one from Microsoft called the Azure IoT suite. So you can see that they will have very similar services to what we see on the Amazon suite. So there's something that actually collects the data, then another one that actually processes or analyzes the data, and finally you have machine learning models that can be built over the data that you collect. So in the case of the IoT from Azure, again, OPC UA, which is basically the interface for industrial devices on the factory floor. They send the information to a gateway that collects the information from the various devices, and these are in turn forwarded to IoT. In this case, it's called the IoT hub, right? This IoT hub is the parallel of the IoT core just now. The IoT hub would then actually also forward information to an event hub. We actually convert it to events. So events may be further sent into an analysis component. In this case, they called there's several ones. Okay, one of them is actually based on time series. Another one is based on stream or streaming data analytics. So you can see that the event hub can be just used to forward the data to different tools. So this now was IoT core, and as I say here, in the case of Microsoft Azure, is called the IoT hub. So this is another scenario. The data is coming in through the firewall, and it's forwarded over to the IoT hub. The IoT hub, just like the Amazon core, supports various protocols. So you can have HTTP based ones, or it can also support MQTT, which is another IoT protocol, as well as others that are popularly used. And this information is then forwarded to various tools that can be attached to it. So one of them was the Sentinel is the Microsoft IoT and cloud security tool. So you can see that on top of just normal security services, because we are operating in a cloud environment, we also want to store information that can be accessed by the Microsoft Cloud Security tool. We can see also that other things that are in here includes the Cosmos database, which is a NoSQL capable database. So for storing information like events and raw data from IoT devices, typically we won't just use a relational database, but NoSQL or non-SQL based databases are useful. So as you can see, this data is passed over to this thing called Event Hub. The Event Hub then can forward it to things like the time series, or you can just forward the events to a data lake that gathers the various different forms of data together. Safe building or smart buildings is another common scenario for IoT or AIoT applications. So data, as you can see, is again coming into the IoT hub. Okay, they didn't name it here, but just the stream ingestion here, basically IoT hub. And that data is then forwarded to other devices like some data enrichments for in terms of analytics. And that data is then passed on to different processing streams. Okay, for example, the time series data. And you can see that Azure Machine Learning Service or Azure Machine Learning Studio kind of tool set can be also integrated into this flow of data. It's bidirectional. Logging security is very much part of this. And the rest of the other Microsoft tools like Power BI, which is a data visualization tool from Microsoft, well integrated into the Office suite. And we have also Event Hub integration as well. So the advantage of Microsoft in the AIoT space really is the very comprehensive AI tool set that they have built up over within Azure environment itself. And the other thing is that there's also a lot of people that use Microsoft Office tools. So there are suites of Word and Excel and Power BI. It really works very well together with what kind of AI services you can deploy in the Azure cloud. That is one of the big advantages in a sense for Microsoft. A lot of the Office tools, Office productivity tools is where they have a very strong stronghold. This is another one, again, a preventative maintenance. Okay, this is similar to the Microsoft, the Amazon one, so I'm not going to spend too much time on this. Again, you can see in terms of the data being collected, this is actually using image data rather than raw sensor data. So we need to do some image classification, image processing data using our AI models on it, our machine learning models. This information is then sent on to the event IoT hub and then the event hub, and eventually stored in the Cosmos database. Time series is one of the special analytics components that they have in the Azure suite, and time series analysis is actually very useful for IoT data, because real world data like IoT data typically occur over a period of time. It's actually the sequence of data rather than one individual value that is important, because when you look at the sequence of data, then you can see the trend rather than just one single point in time. So time series data is actually especially pertinent, analysis is especially pertinent for IoT data. So you can see that we can do this to drive analysis to make predictions, and then we can actually optimize how our factory actually functions. Next, and the final one is basically Google. Now, Google is quite strong in the cloud space, but they are relatively smaller in the cloud space as compared with Amazon and Azure. But they also have an IoT suite, and Google being a huge company, they also have some edge frameworks as well, just like the Amazon one. So Google Cloud IoT Solutions, this is the URL. So you can see that in the Google Cloud, they have a very sophisticated BigQuery, which is a big data analysis tool, just leveraging over their expertise in the search engine, because the search engine actually is built over a very large infrastructure for big data analysis. And BigQuery is actually built over that kind of technology. So it's for querying very huge amounts of data in a very fast manner. Then in this, you can see that again, for Google, they call it the IoT core. This is the part that does the data ingestion, where the data is received from the sensor and then stored in various platforms, and then being basically pushed over to the other platforms for processing. So the event hub, in this case, the event hub equivalent is the PubSub publications subscription event hub that we have, that allows us to convert it events and route the events to different processing streams rather than just one single consumer. And then Google had, just like the Azure AI tools, Google also has the AI platform for building its machine learning models. So this is actually a pretty comprehensive group of tools as well. So you can see that in terms of the hardware, Google actually has the framework down to the device itself. A typical IoT hardware would have the publisher, which sends it out into the cloud. This is the one that goes up to the cloud. And the MRAA is the low-level hardware interface that you'll find in Linux to allow you to interface to maybe a chip-based bus, I2C bus, or SPI bus that actually normally use a serial interface, right? Basically operating at the chip level. So you can, with this common IC level interface, we can interface to things like accelerometer or other chip sensors that we have. So you can see that you can make the decisions. So the IoT core collects the data, and then you can see that they support most of the common protocols like MQTT and HTTP as well. So Google being basically an internet company, they are particularly strong in supporting the internet-based protocols, the web things that we have mentioned earlier under the protocols section. So the HTTP-based protocols work especially well with Google because of their background. Right, they have hardware available, so you can see Google themselves, they partner with folks that will build hardware based on their specification to support the various services that are seamlessly connected to the Google IoT core. So you can see from Microchip, from different providers as well. So this is a Cortex M4, which is a ARM-based processor. So do go take a look at this. Okay, unlike Amazon, they do have quite a bit of edge in terms of coming with a very large group of partners to come up with things that support the IoT framework at the device level. So in the cloud itself, just like the other two vendors, they have ingestion, which is IoT core. Then they have a stream analytics. So they call it data flow rather than stream in this case. But the idea is the same, is for processing data that's coming in the continuous sequence rather than just in batches. And this is based on open source, Apache Beam, which is an open source project. So you can see Google still tries to stay to its heritage as being very supportive of open source software environment, or contributing to open source as well. And that we come to the end of the first part, which is on the three major IoT cloud service providers. The first one being Amazon, so it's very well established. There are edge frameworks as well. Then we have Microsoft, which is a strong in a strong position, especially because of their stronghold in the end automation tools in the office, right? So the office productivity tools is where Microsoft has been providing Word, PowerPoint, Power BI. this strong suite of tools are actually well integrated into the Azure backend services. So they are leveraging on this to actually do processing on the IoT data coming in, and then build the models using their very strong AI platform on Microsoft Azure AI. And from there, being able to push that data down to visualization tools like Power BI, etc. So this is one of the advantages of Microsoft, because they basically have very much an end-to-end picture down to the Office tools themselves, which actually, honestly, for AWS, they are very strong in the cloud. All the cloud services, they are actually very good, but they don't have an Office suite, right, that receives the end data being produced. And lastly, Google, which is just like Amazon, very strong in the back end, in the cloud. Google is definitely very, very strong in terms of scaling huge data processing capability as a result of their experience with the search engines that basically search through billions and petabytes of data every day on the internet to bring us search results in an instant. So that's all, and I will see you in the next set of videos. Thank you for your attention.